This is a bit of a follow-up video. It carries on from my other video on tool nose radius compensation on a CNC lathe. This video is talking about the virtual nose position, which is effectively how you tell the CNC machine what type of tool you're using, really where the point of that tool is. And this can be really important, or it definitely is really important if you're using cutter compensation, or if you use a tool presetter, a device for checking the tool automatically, then the machine will want to know what type of tool you're using, and that's how it knows which side of the setting arm to set the tool to. So it's going to approach that setting arm in a different way, obviously for a different tool. If you look at this tool now on the right here, you'll see that when we actually measure it, it is a virtual point that we're measuring because it's touching at the bottom for a diameter and then on the left hand side to give a length. So in actual fact it's as if that tool has got a sharp point when we're actually checking it. So this is a typical tooling quadrant as you would see it in your manual, your Fanuc manual or your Haas machine manual, with these numbers, and each one of those inserts that you can see is pointing in the direction that it would actually be cutting. So you might understand that, but I'm going to break this down into individual tools and show you exactly how they would look when you're actually putting these numbers in. So this first one that you see, this is a number 1, so this would be put in as a number 1, and it's what I would term a back boring bar. This is typically the sort of operation that you'd see one of these things doing. Now let's look at the second one, which is a standard boring bar, which would come in as a number 2, and this is what this looks like when it's machining. Fairly standard stuff here. Obviously these tools can cut forwards and backwards. You're not just that tool nose, that virtual tool nose point doesn't have anything to do with that. This tool's got the geometry to get around this shape so it can get into that groove. Okay. Now let's look at the number 3, which is really just a standard turning tool, the most straightforward one of all. Obviously the number 2 and the number 3 are going to be the most common ones, which is your standard boring bar and your standard turning tool. Let's have a look at this in action. Fairly straightforward, machining around a shape. Okay, let's have a look at a number 4 now, and a number 4 is going to be exactly the same, but this is a left hand turning tool. Then we come to a number 5, a really interesting one here. It's actually a back face grooving tool, which I reckon is pretty rare, and to be honest with you, I don't ever remember doing this, but that's what a number 5 is, and this is what it looks like in action. Now let's bring in a number 6, which is what I would call a neutral boring bar. It's a boring bar that's cutting pointed like that. It's not really a very good way of putting it, but you can see the shape that it does. I'll show you. This is it in action. Let's look now at a number 7. This is a standard face grooving type tool for cutting into a face groove profile, I suppose you'd call it, really. And this is what this looks like in action. Finally we've got a number 8, which is a neutral turning tool. You may be asking what's 0 and 9, but normally you would use 0 and 9 for a drill, which is just pointed really. So that's what you do 0.9 for, and this is what number 8 looks like in action. So that's all the different virtual nose positions from 0 right through to 9. The thing to remember is with these tools, with the neutral type tools, like this one here for example, you've got to take the Z figure from the center of the tool. It's not one edge, so it can be quite tricky to check these and to set these up, and the same with these, the face grooving tools. So that's something to remember there.